Hey, it is I, SolarLune, back from the grave. No, I was kidding. Not at all. Not at all. Yeah, so I wanted to do, well, hello. If you don't know who I am SolarLune. If you're watching this video, you're probably subscribed to me. If you're not, please subscribe. I'd appreciate it. But apart from that, you probably, you might know who I am. I'm basically an indie developer. You've been subscribed to my channel, possibly. If so, thank you very much. I appreciate it. I think I crossed did I cross? Yeah, I crossed 9,000 subscribers. Check it out. Woo! Let's go, boys. 9,000. Nice. Yeah, so thank you very much. If you've been watching my channel for a while, I definitely do appreciate it, and I hope that you continue to do so, and I hope I continue to make stuff worth watching. So it's been a while. I wanted to do a devlog or video update since the last video. I wanted to do it in the month of November, basically have a monthly update thing. So here we go. November. Here's November's update. It's November. It's November here. Forget that it says 4th of December. Just like it's, yeah. That's my computer is like 8 days fast. So what we're gonna do is I'm gonna talk a little bit about what I've been working on. So basically, I've been working on a couple of different things. One is this dungeon. dngn or dungeon is a package, a Golang package, a Golang library made to allow you to make dungeons, like randomly generated dungeons or maps. And so here we're going to go ahead and run the example. There we go. So basically, there's a few different methods of generating a dungeon, and there's other tools as well, but I'm just going to be talking about kind of the example that you can run and kind of see if you want to, and you can get it on GitHub on my repository there. But basically there's a couple of different methods of generating rooms. The first one is using BSP generation, where basically it places slices. It takes a room, a map of, you know, cells, and then places walls like that vertically and then horizontally and vertically and horizontally, and it does that until basically it ends up with a network of rooms. This isn't quite as good as I'd like it, because basically each room only leads into a maximum of, like, you'll never find more than one entrance or exit into a room. So like this room has one way to get into this room. This room has one way to get into this room. This room has one way to get into this room. Like there's no way to get from this room to this room, because there's already a doorway going from this room to this room. So there's a couple of things I'd like to fix, because yeah, that kind of like there's only one way basically through the map is kind of annoying. It's not as good as it really could be, but it's not bad. It's good for a start, I think. The second method is drunk walk, which basically starts with a random position on the map and then just places walkable tiles around until it reaches a certain percentage. And so that's what we have here, which can definitely it definitely gives a very cave-like feel, very dense. And then the third option is to basically do room placement, where it places a room or a square of, well, it doesn't have to be a square, it can be a rectangle, but a square of some size, and then draws lines between that square and other squares to make a map, basically a dungeon of sorts. Yeah, so I probably should, now that I think about it, add an ability to basically have the lines be like right angles rather than being diagonals. That way you can have a little bit more, you know, clear cut, you know, maps. And then also, it's placing doors just kind of randomly wherever it finds a kind of a hallway like this. Sometimes it works out well, like this. Sometimes it works out poorly, like this. But it's just an example, just a visualization here. And so, as for the actual example of how it works, it's like usual. I try to focus on really nice and clean and easy to use APIs, and so that's what we have here. We got a base room, which is what we're dealing with. So that's basically a map of some size, and so this is kind of what it looks like when you print it out. These X's represent walls. Nothing represents basically a blank cell, like a floor, and then these little hashtag symbols represent doorways. So here we go. We basically create the map, and then we select the map, which is a special struct in Go called a selection that allows you to basically select a specific set of cells and then move forward from there. So for example, here we start off by selecting the whole map for the first generation, and then we remove basically the outer area, and then we fill the rest with X's. So that basically means that we're starting off with the map of, you know, blank space, and we're basically making X's all around the corners here, like that, because we remove out of the selection all of these cells, basically like this, all the cells in between the first row, last row, and the first column and last column. So yeah, that's what we have, and then we generate a BSP, which basically says, you know, which cells should be wall, which cells should be doorway, and how many slices should it make. And then we basically select a percentage of those random floors and put it, substitute in a little dot, which gets visualized when we actually draw the map as these little kind of pit marks, just to make it a little more interesting. And that's how it works. So the actual API is pretty straightforward. It's, yeah, compact, it's simple, and of course there's, you know, it's well documented. There's lots of you know, documentation on basically every function in here. There's nothing that's really like hidden or anything like that, which is good. So that's nice. It worked well. I recommend it if you're interested in doing any random generation. There's still a lot to work on, but at the same time, it's not bad at all. And hopefully I'll be able to kind of improve on it as time goes by. And then next, what I've been working on is paths, which is kind of what you might expect. It is a library for pathfinding, made for games. That's it. That's basically the point. So we'll just do that same thing where we go ahead and run the example here. And so here we go. So now the paths example, it's just pathfinding. So it starts off at this cell here, and then it just tries to find a path to the cell that you have under your mouse cursor. By right-clicking, you can go ahead and take out non-solid tiles, or solid tiles, or add solid tiles. And that's the basic, that's basically how it works. So it's nice and easy, not too hard at all to use. Something else that's really useful is the ability to add different costs to specific cells. So for example, we can say, for example, if we wanted to get across this area, right? Let's see how the path is drawing. So it's basically walking down this kind of line, right? But what if we say, okay, well actually there's like, you know, this is, let's say this is like an RPG or something, and we say, oh well actually like a lot of these cells are impossible to walk on, or next to impossible to walk on, because they have like a, you know, it's like a moat or like a swamp or something. So it's like you're not really supposed to like it's you know, difficult to walk on it. So what we can do is basically raise the cost of some of these cells to make it so that basically the pathfinding algorithm will really rather not take these paths, and instead we see now it just walks around it. Now it just completely tries to bypass those cells. But if we have to take the cell, the pathfinding system can go ahead and basically find the best path that would have the lowest cost, which means basically crossing over as little of the water as possible. So rather than making these solid, we can raise the cost if we need them to be passable, but at the same time not like, you know, ideally you want to try to find a way around it, but if you have to, you can not. You can, you know, the pathfinding system can just say, you know what, I'm not gonna be able to find another way around. I have to go through the water. I have to go through the lava. I have to, you know, do something. And this is useful because basically this would allow for, you know, entities that do pathfinding to kind of figure out the better way to do things rather than just a way or the fastest way. They can figure out like, oh, well, you know, this might be fast, but it would take me over, you know, forest tiles, which, you know, might physically have the same size as normal tiles, but they have a higher cost because it takes longer to travel through forest than it does through normal tiles, right? So with that in mind, you could say, okay, well, if that's the case, we're basically, you know, each tile, you know, has its own cost, and different tiles can be, you know, kind of walkable at different values or not. Some can be better or easier or better. Yeah, better can make for better paths, and some make for worse paths. Then you can go ahead and have this system in place so that you can, you know, have a unit try not to take the forest tiles if necessary, but take them if possible, or if that's the only option. Yeah, so that's nice. So basically, it's kind of like an inherent road system. So you could have it so that roads have a cost of 1, forests have a cost of 5, mountains have a cost of 20. You know, sea has a cost of maybe 60. And you know, there you go. So now you have, you know, a built-in system where all you got to do, even if you wanted to add like a stamina system, you could say just, you know, subtract the stamina from a unit by the cost of the ground they're moving on, and there you go. Now you have a system where basically it's harder and it takes longer and it's you know, takes more of the unit's energy to travel through some methods of movement versus other methods of movement. So it's very, very easy, very nice and straightforward. There's not too much I feel like is missing from this implementation so far. It works pretty well, and the actual mechanics of it is simple as well, pretty simple. It's kind of similar to the dungeon map that I showed earlier, because it's kind of a similar initial visualization in that you start off with, and the easiest way to start off if you're starting with like making your layout yourself is to do it like this, where you have a array of strings. That way you can just really easily, like, you know, move them around, or you know, like edit them like this, or whatever the case is. And then you can just make a new path grid from that string array, and then that's it. At that point, you have the grid, and you can just say, okay, well, I just want to loop through, grab all the X's, and turn them into non-walkables, and then you have a path. The pathfinding system can just look at this and get a path, which we do. Where? Oh, this isn't it. Okay, I'm like, where's the path? Where do I get the path? Which we do in here. Don't I? Let me see. Here we go. Yeah, right there. So basically, in the draw, for whatever reason, I have it here. I have it somewhere else as well. Hold on. Maybe I don't. All right. Well, anyway, it's somewhere in the path, somewhere in here. I guess this is it. Basically, I get the path using the map that we just made down here. So we say world.gameMap is a path grid. Some of them are non-walkable. Basically, the X's are non-walkable. And then we just get a path from a starting cell to an ending cell. And that's just basically using the grid's get function to get a cell. So we say we want to basically get the start cell and go to the target cell. And we don't want diagonals. If we wanted diagonals, we can just change this false to true. Oops. And then when we go ahead and run it, we'll be able to pass through diagonals like that. Which is useful, you know, because you could have, oops. It's useful because you could have, you know, situations where you might want to have units move around around corners, things like that, more easily. So that's nice. Works well. And the overall path has a cost, which is just the accumulation of all of the cells in the path, naturally. And that's about it. There's other functions too, but that's basically the ins and outs of using it. And that's about the process. It's pretty straightforward as well, pretty nice and easy. And yeah, I'm proud of these two libraries. You can get them on my GitHub repository, and I hope anyone who uses them enjoys using them, because they're pretty solid, I think. At least this is solid. The dungeon, I mean, because random generation is so, like, there's so much you can do with it that it's kind of tough, but you know, there's a lot you can do with it, and there's a lot that you can always improve upon to make it more realistic, more natural, more interesting, more dynamic, and expansive. So it's going to be tough to get that to work, you know, effectively. More so, I think, to get to a really nice state and status. Versus pathfinding is pretty straightforward. You know, even this, I'm not sure if it's Jiskra. I'm not sure if I'm saying that right, or you know, any other real method of pathfinding. It basically is best first, I guess you could say. Lowest cost, and best first. It doesn't really give you any alternatives or alternative paths. The path that it returns is going to be the fastest path, or the path, the shortest path rather, or the path of lowest cost. which should be the shortest path, unless you altered the cost of the costs of the individual cells on the path. Well, anyway, that's about it. If you want to find them, check them out on my repo, my GitHub repo, and hopefully they'll be useful to somebody and you'll enjoy using them. So thank you very much for watching. I've been SolarLune, and I have actually a devlog video to make on my next project. I probably will be making that just like right now, but that is in itself a large thing to talk about. So I'll save that for another video. This is already running a little bit long. So thank you very much for stopping by, watching my channel, watching my video here, and I hope you have a wonderful day, and catch you guys on the flip side. See ya.